All right, good morning, everyone. It's a beautiful day in the Charm City, and today Nimish and I will be talking about cloud security. So, just few disclaimers: we are not representing our employers today, and whatever we are kind of talking here are ideas from our research which we did last year. And apart from that, if there are any questions, feel free to ask throughout the session. What we will be discussing today is something around cloud security. So a couple of pulse check questions. How many of us are working on cloud environments or running our workloads on cloud? All right. Almost all of you. Okay. So with that being said, let's quickly check the agenda for today. So the talk is titled Harboring No Illusions and Navigating Risks in the FaaS World. So as we all understand, FaaS stands for the serverless kind of workloads, what we see, which includes the Lambda functions, ephemeral compute, and whatnot, right? So to begin with, the agenda looks very straightforward. We will talk about the evolution of infrastructure abstraction, which we have seen over the past few decades. And then we'll move on to kind of examining how the attack surface has changed from the traditional operating models. And then we'll talk about some economic impact of the serverless incidents, what we have seen in the past. And we will do a case study of how we can secure AI workflows which are built on serverless environments. And finally, we'll have the key takeaways and some ship to Monday insights, which we'll share with all of you. So with that being said, let's dive into it. So the first slide for today talks about how the infrastructure has evolved over past couple of years. And to begin with, what I would like to call the first phase is the bullock cart era, where the physical servers were running. There was one operating system, one workload, and that's the bare metal era, right? So what would happen at that time? You owned the entire cart. There was just one cart, one destination. You fed the bull, you fixed the cart, you cleaned the mess, you did everything basically, right? So that's the bare metal. It was predictable, yet it was painfully slow to scale. And guess what? Some of the critical routes still use bullock carts today, which means we still have the on-prem servers around. And I think it's for the good because there are a couple of industries or there is some information which we want to still, kind of use the on-prem systems for, and that's why they still exist. And now coming to the second phase, probably it's the virtualization era where we saw there was one physical server and there were multiple kind of virtual machines, and we also call this era as the bus or the carpool era, right? So the road is the same, engine is the same, but multiple passengers and different destinations. So what happened here? There was better efficiency, faster recovery if one ride dropped off, and fewer empty seats. But now the problem was we need to now have a schedule, right? So we need to have tickets in place, we need to have rules, or otherwise chaos would follow. So welcome to the early cloud, where we had the infra, where the infra became elastic and scalable. So it unlocked the better resource usage per se, faster recovery, flexibility, and here is where the tools like VMware or hypervisors, AWS, EC2 instances, they kind of changed how we thought about compute. And as the applications grew, teams wanted something lightweight, more portable environments. That's where the containers arrived. And with Docker and Kubernetes coming around 2012 to 2013, developers now could package their code, dependencies, not now worry about the environment where they're running it, whether it is local in some other environments. So they could no longer have that excuse that it's running in my system but not in yours, right? And this was the era of DevOps, automation and microservices, bringing that agility and also some orchestration complexity. And then finally, in 2014, is when we saw AWS launched Lambda, marking the start of the serverless era. Also called as teleportation, because now you don't book a ride, you don't see a car, you just appear at your destination, which means you upload the code, trigger the event, and done. So it accelerated innovation for sure, but it also blurred some responsibilities because developers lost the insight into what was kind of under their control once. And that's the agility which serverless brought. But it also brought in some new risks, and that's the risks which we'll try to uncover in today's talk. Now, as we already spoke about, each layer of abstraction which made our life easier also kind of added some distance from the underlying system. And that's where we are calling it as the evolution, where we don't have servers anymore to manage, but then what are the other things we need to still take care of? So that being said, the next slide up here talks about the shared responsibility model in the serverless environment. And here we see the markers in yellow, they represent the cloud customer, and the markers in purple, they represent the cloud provider. So from top to bottom, it talks about how the responsibilities have shifted. Now, if we go from left to right, in the on-prem era to the FaaS world, how the responsibility on the cloud customer is kind of reducing, and while the cloud provider is having more onus on them, either if it is data class in terms of client and endpoint protection, or in terms of application level controls or network controls and other details. Now, the key here is definitely how we apply these DevSecOps principles, like validating the inputs, restricting the IAM roles, audit configurations, monitoring some function behavior. So that still stays with us. And with that, let's now talk about some serverless attack surfaces. So to begin with, we have the first kind of classification, which is the trigger and the event source risks. Now, why we talk about this here is because this is the front door for a lot of our risks coming in. It could be coming in through some SQS, which is a queue-based system, or it could be a messaging coming from an SNS, or the API gateway per se, right? So what are we talking about here is how do we validate the inputs which we are receiving at the edge, right? And on the similar lines, there are other class of vulnerabilities, which is the functional level vulnerabilities. Now, when we talk about these, what reminds me of that is how we deploy our core packages to, let's say, Lambda functions, right? So we do have packages involved, there are third-party packages involved there, and how risks from that can make your entire application more vulnerable. Then the third class of the risks here is the platform misconfiguration. And in here, there are certain pointers which you can see on the screen as well, which talk about how disabled logging can basically lead to some kind of loss in the forensics in general, and how we can have the guardrails in place to ensure whatever misconfigurations we are having in the cloud resources which are getting spun up in our environment, those we get alerted on time to time. Now, the remaining two classes are a part of the platform misconfigurations, but they still need a special mention, right? Like the one which says CI/CD risks, those are the risks which can come in through our pipelines, and how we want to ensure that we have more safer packages being used in general. Let's say we can use dependency versioning or pinning in general, or kind of manage it through SBOMs, which is the software bill of materials. And then talking about the monitoring gaps, how we can have the right telemetry in place, which also means we need to have the right logs, and we need the ability to query those logs time to time whenever we feel that there is a need to do that. And also those help in understanding the threat activity in general. All right, with that being said, I'll hand it over to Nimish from here, and he'll talk about the threat mapping to security frameworks.
Well, thanks, Shivam. So a basic tenet of this session is that serverless doesn't remove responsibility, it sort of relocates it. Now, after speaking with different GRC analysts working within the space, be it cloud or specifically serverless or FaaS, function as a service being a subset of cloud environments. The GRC analysts working within governance and compliance for monitoring and assessment for function-based servers, services and applications, we found that in addition to security engineering constraints associated with the infrastructure abstraction within the serverless architecture, risk assessments, and building accurate RACI matrices is another major sort of challenge from a governance perspective. So this table sort of maps 3 high-impact serverless risks to 2 popular frameworks, the OWASP, or the Open Web Application Security Project Top 10, and CWE, which is the Common Weakness Enumeration Top 25, and sort of pair each with concise mitigation steps that you can ship sort of come Monday morning. And again, this is like AWS standard, but they can be translatable to other cloud providers as well. So first one is platform misconfigurations. Now in serverless, platform is your runtime. So the OWASP equivalent for this is security logging and monitoring failure, and the CWE, insufficient logging. With the misconfigurations, especially missing or weak logging, essentially, they turn incidents into sort of silent failures, which are gradual and they're not very, obvious to be detected, or that's something which is which can be flagged within the detection engineering part. Now, as if you can't see it, you can't defend it. So for mitigation strategy, capturing the right logs by default is fairly crucial. We can do that by enabling, again, this is AWS specific, but CloudTrail or Lambda and API gateway logs, S3 data events, and VPC flow logs. That is specifically for egress paths. And now enabling logs is just the first, although an important step, but we also need to make the logs useful. So for that, we need to sort of structure them, say based on principal role, request ID, any resource ARNs, and consolidate and centralize them into a SIEM solution. It could be open source, proprietary. There's so many other options out there, but that needs to be integrated with detection rules for anomalies, such as sudden spikes in the invoke function, or get objects from new roles, or cross-region copies. If you don't want to, this SIEM solution, AWS provides their rendition of SIEM as well, but there are so many, there's different other options as well. Second is the runtime monitoring. That's part of the mitigation strategy. And this can be achieved by configuring CloudWatch metrics and alerts for sort of error ratios, throttle spikes, and cold start anomalies. Moving on, the second risk is event injection, or just injection within OWASP and improper control of code generation within the CWE. Now, serverless apps are essentially event fabrics that are knitted together using a plethora of API requests, S3 object pulls, SQS messages, schedulers, and many other different aspects that come together to essentially build and implement a serverless application. Now, each event, in this case, is an ingress point, and event injection captures the risk of unvalidated inputs, forcing unintended behavior, code paths, or even straight-up denial of service. So the mitigation strategy primarily revolves around configuring boundaries to enforce at the edge. Now, that can include schema and content validation at the API gateway. The API gateway security can reject any malformed JSON, oversized payloads, any rogue headers, or any unexpected, MIME, which is the multipurpose internet mail extensions, or the types before the function runs. Second strategy is strong identity on events. That could be using the JWT authorizers, configuring MTLS if it's feasible, or even enabling signed URL requests if you say want to grant temporary access to files or objects. Now, in addition to the secure authorization, we can even use S3 event filters and that refer to the least privilege notification topics to utilize other attribute-based access control. Now, another sort of cool technique can be configuring fail safety. Now, that can be done by using DL queues or dead data queues as async triggers. and idempotency keys to prevent replay, and rate limiter and WAF rules for, obviously for Percy probes and other, custom ACLs. Now, the core objective essentially is that if an attacker injects into the stream, these boundaries sort of stop the lateral movement and restrict the blast radius. Moving to the last one, that's the vulnerable dependencies or the vulnerable and outdated components in OWASP and use of unmaintained third-party components within the CWE. Now, in serverless, dependencies are part of the supply chain that are embedded within the Lambda layers or container images and transitive packages. In this case, for mitigation strategy, we can utilize steps like producing an SBOM with tools like Maven and verifying signatures for images or layers and blocking any unsigned artifacts within the CI pipeline. Good practice is to scan early and scan always, and it's also a good strategy for runtime protection. Now, SEA scans, software component analysis scans, could be used to analyze open source components. The static or dynamic application security testing, SAST or DAS scans, they can be used for analyzing sort of the code functions, both before and after execution. And image scans can be done on the pull requests. So you can configure something like fail builds for critical and known CVEs, and schedule rescans on a cadence, confirming with your sprints. Third one can be constrain egress and a sort of third-party access. That is also that includes different steps like PPC integration with the egress controls. Now, essentially, the result is fewer moving paths within the serverless, which is dynamic in nature and abstracted, fewer surprises, and less attacker leverage through your build chain. Before I move on to the economic implications part, I would pause to see if anybody has any questions. I think that's a good crowd. Well, so moving on, this section often sort of gets management's attention. So anybody who's a CISO or who is a decision maker within their company, within their organization. So it's typically, good to have these stats handy. We've established that obviously serverless isn't a silver bullet, and the responsibility shifts. So, what's the sort of economic implications of that? Now, in this chart, it illustrates the exponential growth of the serverless computing market, and we are talking, about a market that was almost like 19 billion in 2024, and is expected to be around 50 billion by 2030. It's not which kind of says that it's not a trend. It's a sort of like a shift that is driven by like actual genuine benefits, like reduced deployment cycles and faster shipping. And obviously, we use FaaS and serverless interchangeably. That's also because statistically, 61% of the serverless computing market is driven by the function as a service. And I would say a major chunk of that is contributed by the Lambda functions. So now the growth, however, also magnifies the risk, which is why we have the second graph, which sort of relates to the projected losses due to serverless-related breaches. This was created by forecasting on certain known breaches that were directly or indirectly related to serverless. Now, the damage isn't just direct, it also incorporates the cascading secondary losses. So obviously, as the market grows, so will the losses associated. And the base, high, and high plus is sort of like three different scenarios that have 30% increments. By increments, it essentially means that we are, that's the liberty that we are taking in terms of the forecasting. And across all of them, the loss runs into like, hundreds of millions. Now in the next chart, that is for the cyber insurance market. Obviously, you can, that's also increasing the share of the insurance market. And serverless isn't the only contributor, but a major one. And I would say now with the agentic AI and the other emerging threats as a consequence and as part of it, I feel like the numbers are not accurate anymore, to be honest. So the growth is not just from the companies buying the policies; it also reflects the underwriting, reacting to these losses essentially. So that being said, we will shift back to our technical part of the session and we have a case study. Essentially, this is regarding a open source cloud utility setup. We've named it as LynxLab, and we have sort of a introduction of that architecture diagram and a quick demo of how to create the stack for that. Now, it's a sentiment analysis model, but we are leveraging AWS's Bedrock. It has several pre-trained models. It can be swapped by other classification, machine learning models as well. That's the most practical one that we thought would be good to demonstrate, but we can definitely have an LLM model in there as well. Obviously, that changes the diagram slightly. So coming to that, the workload itself is sort of intentionally simple. It's a sentiment analysis flow, which essentially, you pass on a review or a text, and based on natural language processing algorithms, the output comes back as whether that text, which could be a feedback or a review, whether its sentiment is positive, negative, or neutral. Now, the simplicity is deliberate because it keeps the focus on the actual security controls, trust boundaries, and failure sort of modes, which is what we are interested in, I'm sure you are, rather than on the application or the model complexity itself. So tracking the lifecycle of the process, I'll start from the left, in which the user obviously sends a request through the API gateway. Now, this is the public entry point, and in a realistic serverless system, this is where controls such as authentication, authorization, throttling, request inspection, and input validations are typically sort of enforced. And behind the API, we have two separate Lambda functions with obviously separate responsibilities. We have the authorizer Lambda, that is sort of like the bouncer. It handles the access control and determines whether the request is allowed to proceed. The worker Lambda handles the business logic and orchestrates the call to the actual model, which in this case is the Bedrock model, or the sentiment analysis model. Now, the authorizer is, as you can see, also integrates with the secrets manager. This is important now because we do not want any credentials, tokens, or any sensitive configurations hard-coded in the code or deployment settings. Now, the authorizer retrieves what it needs securely. It validates the caller context and determines whether to allow or block the request based on the rules. We also have an S3 bucket in the workflow. Now, that gives us a place to record requests and response artifacts, which is sort of useful both from an operational as well as from a security perspective, because it creates an evidence trail for triaging and any post-incident DFIR, forensics analysis. Now, the right is the model layer, which is from the Amazon Bedrock, AWS Bedrock. Now, in this particular example, we have the Llama 3.8b, which is a very common sentiment analysis pre-trained model. But we do have, as of this year, I think it's been retired. So if you search for it, it will not come up. We do have an alternative. It's called the Nova Micro V1, in case anybody is interested. The worker Lambda, which invokes the Bedrock model, that receives the sentiment result and returns the response back to the same API gateway, essentially, to the user. Now, the diagram is just that. It's simple, or at least it looks simple. But I would add a footnote, and that is based on what happens. We had a question that how do we, Bedrock now even has the agent core, I think, so which basically it has like different AI agents now that have some actions that can be utilized, like pre-configured actions. So we had a question that can that be swapped one-on-one with this Bedrock model? So for that, the agentic version will not be completely different, but will not be the same as well. So what it does is that it essentially adds another layer of orchestration on top of it. Now in the basic flow, the worker Lambda mainly acts as a request handler that sort of sends the prompt to the Bedrock model and returns the response. Now in an agentic orchestration, the middle layer becomes sort of much more dynamic. Instead of doing just what one inference call, it can plan the task, decide whether it needs retrieval, call any other tools that are downstream or other Lambda functions as well, and pull or store the artifacts within the S3 bucket. It can also loop back to the model until it has enough context to send back the output to the user. The key shift is mostly from a single step generation to a multi-step decisioning and action execution. Now the API gateway, authorizer, secrets manager, and the storage pattern, that can essentially remain the same, but the worker layer that's the one that evolves into an orchestrator and is, can be replaced by a Bedrock agent or a step functions-based orchestration flow. And that's what makes the architecture more agentic in that sense that we just have one additional layer of orchestration in the middle, which is much more dynamic than the current one. So this is, we do have a demo for, yeah. So this is for essentially the stack setup. The main idea here is that we treat the infrastructure as disposable. That's the whole idea of serverless as well. Now we create the environment, validate that it works end-to-end, and we use it for testing, and we also tear it down because it's reproducible, so it can again be configured whenever you need the stack. So now that matters from both a security as well as engineering perspective because it makes the experimentation sort of safer, it reduces the drift, and also lets us rerun the exact same scenario without rebuilding everything manually each time. And the video, this is like a CLI-driven workflow. The process is pretty much straightforward. We install the required Python dependencies. We configure the AWS CLI credentials and the region. We set the environment variable used for API authorization. And then we run the driver with a create action. The create action then provisions the entire stack, which is what it's doing right now, which is also what we saw in the previous slide. Now, we are switching over to the AWS console. Essentially, the purpose of the next step is the verification. We want to confirm that the resources are actually appearing the way we expect them to appear, and that the architecture we described is, it has been really deployed, essentially. So practically, that really means that checking the API gateway exists and the authorizer Lambda is attached to the API root. The Lambda worker is present with the correct permissions, and the supporting services, obviously such as the S3 bucket and the secrets manager, they're also in place. So it's a verification of the essential requirements for the application. I think in this case, it has the verification part is succeeded. Yes. I think now we have essentially the worker Lambda is executing. So the worker is the function that will handle the business logic, as we discussed. It reads the request parameters, prepares the call to the Bedrock model, and sends the inputs for inference, receives the result, and then returns the result back through the API response path. Now in LynxLab, the worker also writes request and the response artifacts into S3. And we can also have it connected with DynamoDB if you want to store the responses in the form of a database as well. Now, this part, the S3 storage is obviously useful, for not just for the logging, effective logging, but also for the reproducibility, because we can compare the runs over time, and we can, map whether there are any discrepancies. We kept the demo, recorded intentionally because, demos don't rarely fail if we, in addition to, as opposed to, doing it live. So yeah, that's good. Yeah, I think that's about it. Yeah, so we have the stack ready, and I think the last part is just the check, the verification of the responses, and the destruction of the stack. With that, I will pass the buck back to Shivam, and he will now discuss about the attack and defense scenarios, specifically to our serverless application.
Well, thank you so much. Couple of things here. I guess one thing was the services what we have used here are all part of the free stack. So anyone who is interested in checking this out can go in, and there's a QR code right there which links to the repo as well. And everything is free in the AWS tier, and that's why we use those services. And those were part of the serverless stack as well, and that helped us kind of, frame the idea around the session which we were planning today. Also, we had a training yesterday where the same LynxLab was deployed by a couple of folks who joined us, and we were happy to see that almost everybody was able to deploy that on their respective AWS environments. And there were a lot of good questions which came out of that session as well. But yeah, please feel free to check this out and see how you guys can also contribute, or if you have any plans around making it cloud agnostic or anything for that matter, feel free to reach out to us. Now, with that being said, I think the primary focus for our conversation today was around how we can have the attacks and defenses in place for the serverless environments. And in this case, we have taken an example of the first one, which we see here as the trigger risks, part of the malicious inputs. So the one highlighted there in yellow towards the end, where the user is also added, shows how the inputs can be fed into the system, which is via the API gateway. So let's say if you have a malicious payload, how would the system respond to that, right? I think that's the quick defense which we want to implement, is validate the inputs at the edge. Have the schema validations done at the edge, and also which ensures that, let's say, if there is some constraint around the content length which you want to pass in, because finally this interacts with the bedrock model as well, that helps you trim the content and only pass in the required information. Moving on, the second category of risks which we discussed earlier were the platform misconfigurations. And here, for example, when we're talking about the authorizer lambda, already Nimish walked us through why it is used. So I think, as we all know, we want to know what is going on, who is invoking that lambda function, when is it being invoked. So let's say if we don't have the proper telemetry around those actions, right? What happens? So I think that's where the platform misconfigurations come in place, because we will have those guardrails which will kind of alert us on the specific misconfigurations around it, and that will help us alter our platform or the environment in the way it will become more compliant. Then moving on to the third category, which is the functional level vulnerabilities. And here, as we see, let's say our lambda function is using a kind of not so safe package, and then it tries to kind of take the input from the secrets manager, like kind of access the secrets manager and get the secrets out from there. I think that's what we're trying to say, that could lead to a leaky secrets attack. And how can we ensure that the packages what we are using, which is the third-party packages, are safe, and we don't have the vulnerabilities in the deployments what we are having for the lambda functions. And for that matter, we can have the quick defense as dependency pinning, where we ensure that the right versions are being used in our environments, and also the other kind of defense strategies include the maintenance of SBOMs. So that covers the attack and defense scenarios. We also plan to have simulations of the same in LynxLab going forward, and we are planning to kind of make it in a agentic way. But we'll see, I mean, how we can have these three use cases primarily kind of showcased via LynxLab's tech stack. And off to the final key takeaways. All right.
The serverless, as we know, it removes the servers and the need to understand what is actually happening. Now, if you cannot trace the full path and permission boundaries, you sort of end up doing these mental gymnastics during the incident triaging process instead of having like clear clarity on the controls and visibility upfront.
Yeah, so you still own the identity, data, dependency, and configurations.
With the abstraction and hyper-scalable function triggers, shipping gets easy. So you definitely want to move faster to prod and also get that non-technical PM off your back. But if you're not gating your deployments with automated security checks and least privileged reviews, you would end up throwing up during the sprint.
Right, and that's where the structured velocity comes in place. We want to ensure the production pipelines are kind of enhanced via structured velocity, even for the serverless environments.
I think we had a question yesterday about structured velocity. That just essentially means following the playbook. The dynamic nature of deployment can definitely get enticing, but we definitely need to have a similar playbooks for the serverless level deployments as well. The third one, isolation is a design choice, not just a vibe.
Of course, because it's a blast radius management, and you need to isolate by function, by the account, by VPC, and by the tenant. Next.
Function-driven, highly abstracted workloads can definitely feel like the compound V for production, because it enables faster shipping, auto-scaling, and obviously fewer servers to babysit. Now, but the same sort of trust me bro abstraction can catch you off guard during the incident response if you do not enforce trust boundaries, validate inputs, and isolate event permissions.
All right, so for third time in the talk today, you need to validate schemas at the edge and keep your handlers small and idempotent.
Now, this is what a serverless architecture essentially feels like without having comprehensive telemetry. Everything sort of feels fine until it doesn't.
Right, and you need the traces to follow an event across the services and logs which you can query at the right time.
And the last one, serverless changes the shape of the risk, and it's, I think, our job as security practitioners to design for failure.
And remember, you lose the server, not the responsibility.
Yeah, that's about it. We have a grown-up version of the Panda which is muted.
Which is muted, right.
It's just thanking everyone and wishing everybody a good rest of your conference. We didn't realize that there was no voice.
Yeah. All right. That's our talk today, guys. Thank you so much. We can wait for any questions.
I have one question.
Sure.
Your graph showed that there were $20 billion spent on insurance in 2026 and $60 million in losses. This sounds like a 300x value proposition for insurance companies. Why aren't we all in insurance?
That's a question I've asked so many times whenever I'm filling out those forms that we get from the cyber insurance companies. And it's like, you ask for so many information and they just have like two people, who are like, oh, this is all what we cover. I mean, they make good money, and we're the ones who are filling out the form. I don't know if you guys are following, but a lot of cyber insurance companies, especially the insurance companies that deal with cyber insurance, they're also acquiring a lot of security companies as well. And I think specifically, Beasley, it's a UK-based, I think. They're a big cyber insurance company, but they have made certain acquisitions, and now they're offering like an entire security stack. And what they essentially say, oh, if you take, if you take these services, your premium's going to go down. So that's a great strategy. Yeah, I'll also like to reiterate for the LynxLab, we are also definitely open for any contributions. So if you have already scanned the QR code, if you have the link for the repo, definitely check it out. And yeah, if you have, you please make any contributions as well.
All right. Thank you.